Hello Algebra 2 students, and welcome to our video reviewing systems of equations and learning how to solve nonlinear systems of equations. We're listening to Bankrupt by Phoenix. And I'm in my classroom, so it's pretty likely that the heat's going to kick on and you probably won't get to hear most of the music, and I apologize, but it's pretty good disc. We can always play it in class. Okay, so this is one of those topics that we just sort of wedge into the year. Systems of equations we learned how to solve in Algebra 1, so you'll see some review of that here. Nonlinear systems, we're talking about other shaped graphs, like parabolas, so you know your parabola, ellipses, circles, which you learned about in geometry, and something called a hyperbola, which is a graph where they go in opposite directions, and you'll see what that is. Now, we're not going to actually learn anything about those, except I'll just give you an overview. What we're going to be learning is how to find out where two of them cross. So as you can see, this is one of those topics they just sort of shoved into Algebra 2. But we'll make the best of it. Let me look up the page number for the purple textbook real quick before I continue. It's 577. Okay, let's talk about systems. Okay, a system of equations, a set of two or more equations that are graphed together. The solution of a system is the set of values for the variables that makes every equation in the system true. Usually that's an ordered pair where the two lines cross. A linear system includes only straight lines. A nonlinear one is one where there's going to be one or more curves or conic sections. Okay, linear systems. You've got most of the time the two lines will intersect, and that's your solution, is the point where they intersect right there. And that's a consistent system that has an independent solution. Sometimes the lines will coincide, and this is where you had two equations, but you couldn't tell that it was actually the same line twice. And that's infinitely many solutions. In other words, every point on this line is a solution. You will not see this with nonlinear systems. You will not see this. You will, however, sometimes see the third possibility, which is no solution. And that with lines is where they're parallel. With conic sections, that's going to be where they just do not intersect. Let's solve one quick system. Oops, sorry for the formatting there. It looks like my images are a little off. We can solve this by any of these different methods, whether it's substitution, elimination, or graphing. I want to go over what substitution and elimination are, and then I'll do a quick graph. I'll pause it, do a quick graph so you can see that. Okay, substitution first of all. Substitution is where we take one of the equations and we solve for one of the variables. And since this y is alone, we're going to get that y alone. And that means that y can be replaced by negative 2x plus 10. So we take that first equation, and instead of y, we're going to replace it with negative 2x plus 10. And then we're going to solve that equation. So 3x minus 8x plus 40 equals 12. Negative 5x equals negative 28. And so this is not coming out very nice. I'm not liking this system at all right now. But we trudge on anyway. So x equals 5.6. And then if I go back and I go ahead and plug that in for x and I solve for y, I'm going to get negative 1.2. So I know I kind of sped that up a little bit. But that's the nature of substitution. What about elimination? What's that? Well, let me go through and erase my work here. So let's look at elimination. There we go. So elimination, I didn't quite get all of it, but that's okay. Elimination is where we're going to take the two equations and we're going to add straight down to eliminate a variable. But we can only do that if it's set up for elimination. So what I'm going to do is I notice, again, since this is 1y, I'm going to take that second equation and multiply by negative 4. What that's going to do is give me a situation where if I add straight down, the y term will eliminate. So let me multiply through this negative 4. So negative 8x minus 4x equals negative 40. Add straight down, it eliminates. Positive 4y minus 4y. We get negative 5x equals negative 28. And again, we still get that same answer, 5.6. And we can go back, plug that in. And so that's the part where you kind of use substitution again in the elimination. Plug that in and find y. Then the other way would just be to graph it. So let me do a quick graph. I'm going to pause pause the video to do it so you don't have to watch me go through the process of graphing and waste all that time. And there we go. And there's our solution right there. So we can use substitution, we can use elimination, or we can use graphing. Let's take a look at some nonlinear systems. Okay, so basically what you're going to have is one of the two curves on the graph is going to be a parabola most of the time. So there's a parabola and a line, and you have lots of different ways that this can come out. You can have a parabola and a line cross at 2 points. You can have a parabola and a line be tangent at 1 point. You can have them not cross at all. And then there's lots of other possibilities. Think, for example, about the possibility when you have two circles. You could have two circles that do not intersect at all. You could have two circles that intersect at 2 points. And you can have two circles that are tangent. Think about the hyperbola thingy that I showed you, for example, or I actually haven't shown you yet. Let me show you what a hyperbola looks like. It's like a parabola with a mirror image of itself on the other side. So if I have a hyperbola, I could have a circle, and the circle and the hyperbola could pass, it looks like a tennis ball, they could pass at 4 points. So these systems can have 0, 1, 2, 3, or even 4 points. How could it be 3? Well, think about a parabola and a circle. Say it's tangent on one side, but it crosses it on the other side. Look at that. 1, 2, 3. Crazy, right? Let's try some of these so we can see what they're going to come out to be. Now, most of this is algebraic in nature. You're not going to see a whole lot of images when we look at this. Okay. All right. But before we actually do one, let's look at these images. This is what we mean by a conic section. So here's a cone. Slice through the cone. If I slice through the cone parallel to the base, I get a circle. The cut edge is a circle. If I look straight down at it, okay, whoop, that doesn't work. I have to have a different, let's see. Oh, none of those will arrow down. So if I look straight down at these images, this is what I'm getting. If you cut on an angle, you get an ellipse, an oval, okay, math word for oval. If you cut on an angle but down to the base of the cone, you get a parabola. And the hyperbola actually comes from what it is, and this is a little confusing, so let me draw a quick picture. Okay, what it really is there's actually another cone right here that's identical, and the hyperbola is cutting straight down through both cones. And that's how you get the two cut edges. So you'd have the cut edge on the top and the cut edge on the bottom. That's the hyperbola. And that's what they all look like. Now, it doesn't matter which one is which. We will talk about it in class when we practice with these, and I will help you see when it's a parabola, a circle, an ellipse, or a hyperbola. But it's not part of what you need to know. Hence my allusion to the fact that this is one of those topics just sort of shoved into our Algebra 2 curriculum at an awkward place. But they're not hard to do. They're not hard to solve. Let's look at them. Okay, now we finally get to our examples. So for a question like the first one, we have a parabola and a line. I don't know where they are. I could graph on the calculator, so you absolutely could graph that on the calculator and take a look at it that way. That's not a problem for me, but we're going to learn how to do it on paper. We're going to use substitution. If both of them equal y, then we can set these two right-hand sides equal to each other as one equation. So negative x squared plus 5x plus 6 equals x plus 6. So we're going to be solving some quadratics. I know you're super excited about that. We're going to subtract the x and the 6 from both sides and get negative x squared plus 4x, and that's 0. Okay, so equals 0. And that's easy to factor. That's easy to solve. We're just going to pull out an x. And I can pull out a negative x. It really doesn't matter. I can multiply the whole thing by negative 1. In any case, we're still going to get the same answers. So let's do that. Let's x squared minus 4x equals 0. Let's factor out an x, leaving x minus 4. Giving us two solutions for x. X is 0, and x is 4. So that means I have two different ordered pairs. One of them is 0 something, and the other one is 4 something. And what you're going to do in order to find what that something is for the ordered pairs, the y values, is you're going to plug the x in and find the y. So y equals 4 plus 6 for the ordered pair that starts with a 4, so the y is 10. And y equals 0 plus 6, and so that one is 0, 6. All right, and those are the 2 points where where that parabola and that line cross. And why don't you go ahead and punch that in your calculator so you can confirm that visually. Always helps to be able to confirm it visually. All right, this next one. What we have here, this one right here, this is a hyperbola. So this is that funky one I showed you with the opposite sides. And this right here is an ellipse. If the coefficients on the x squared and the y squared were the same, it would be a circle, but because they're different, that's what gives it the oblong shape. This is a good one for us to solve with elimination. So I'm going to take the second equation and subtract it from the first. So I'm going to put parentheses around that and minus sign. X squared minus x squared cancels. Negative y squared minus y squared, 9y squared is negative 10y squared. And 9 minus 160 is negative 160. This is going to work out nicely. You divide by negative 10, you have y squared equals 16, which means y is plus or minus 4. Don't forget the plus or minus. That's giving us two different ordered pairs. So now we're going to go back, and we're going to plug in that plus or minus 4 into one of the two equations. I'm going to use the first one. So x squared minus, when we put 4 in there, it actually doesn't matter if we put a positive or a negative 4 in there. They both have the same outcome. So we actually have 4 ordered pairs here. We're going to have two different ordered pairs with a y value of 4 and two different ordered pairs with a y value of negative 4. So what we're probably looking at is an ellipse and a hyperbola intersecting, like the ellipse in the middle and the hyperbola crossing over both sides. X squared minus, so that's going to be 16. X squared minus 16 equals 9. Add 16 to each side, we get x squared equals 25. Convenient. That means x is plus or minus 5. So we go up here. You have a positive 5 with a 4y value, and you have a negative 5 with a 4y value. You have a positive 5 with a negative 4y value, and you have a negative 5 with a negative 4y value. And those are your 4 ordered pair solutions for that system of non-linear equations. So this is not that hard. Okay, it's a bunch of elimination and substitution. The problem I have with it, and I know I've said it like 3 times, I'm sorry. The problem I have with it is that it doesn't seem to have any real application or purpose in what we're doing, as usual. So let's just keep going through the motions. We got 2 more. Okay, a couple more. I want you to try these on your own, except I have a substitution to make. Hold on. I started to solve that second one I gave you, and it was just truly, truly hideous, and I had to change it. So I found this this green one real quick online. So pause your video, try it yourself. They're not too bad, and when you restart it again, you'll be able to see the solutions. Okay, have at it. Ta-da! Okay, I used substitution for both of them. You could easily use elimination for the first one as long as you subtract, because you could eliminate the y's. So if you prefer elimination, you could use that way. There is not a way to use elimination on the second one, unfortunately, when one of them's linear and the other one is, in this case, what is this one? Does anybody know? Anybody know? It's a circle. I heard somebody say it. I didn't really, actually. But anyway, those are the 2 points where they cross. So, just to reiterate, what we're looking at here, this one was 2 parabolas that crossed, and they crossed at 0, 5, and 2, 1. So maybe one of them looks like this, and the other one looks like this, something like that. I don't know. And then this is a circle and a line. And let's see, negative 4, 1, and 1, negative 4. It's like, I'm not sure, something like that. Anyway, these aren't that hard. We'll practice some in class. And with that, I will say goodbye, and I will see you in class.